going to try and do this again. We are just starting a new chapter with systems of equations. And so the first section has dealing with graphing systems of equations. So when we think about what lines look like as we're doing linear equations, let's consider their slopes. So a positively sloped line is going to go up from left to right. A negatively sloped line will go down as you read it from left to right. In between negative and positive, a slope of 0 would be just a horizontal constant function. This would be something that would look like y equals 3. Whereas undefined, there is no way to talk about how quickly that line is changing up or down. So it's undefined. That's like saying x equals negative 2. Okay, so that's a little bit about what lines you should expect to see as you're graphing. Typically, we write lines in slope-intercept form, where m is our slope, which we call the rise over the run. Okay, and b is the y-intercept. Okay, so we're going to move on along to a couple problems here. So two lines can be related differently. They can be consistent or inconsistent, dependent or independent, and you should reference a different image for that. Okay, so looking at this right here, I'm going to start off with color coding this first equation. Already in slope-intercept form, negative 2 means negative 2 over 1, and 6. So I'm going to start out by going up 6. From here, I'm going to rise negative 2 and run positive 1. Okay. So we would repeat this several times until we can get our line to do what we want it to. So we'll just say it goes here. We'll pick a different color for the bottom one. Let's go with blue. So this one, again, our y-intercept is a 2, so I'm going to go up 2 spaces on the y-axis. My slope is a positive 2 over 1. So from that point, I'm going to rise 2 and run positive 1. And we would do this again and again. So what we have here is these two lines. Now, this particular system does intersect, which means that it is consistent. You can see the two different lines, they are independent. You want to write your answer as an ordered pair. So that's x is 1, 4. Sorry about those interruptions. We're going to try and make it work though. If we have one like this, you might not notice what the slope and the y-intercepts are. So I'm going to go to red and say this really means if you don't see a number, it goes right through the origin, or it's plus 0. From there, up 1 over 2. Okay. Next, I have the negative 1 slope, which is like negative 1 over 1. We start at 3, we go down 1 over 1. Okay, so again, we can see that this particular system is consistent and independent because it has one solution and they intersect at the ordered pair 2, 1. Okay, a couple things with this example. First of all, my top equation only has an x, which means it's going to be the undefined slope. So I find negative 3 on the x-axis. And I think about the other points that have an x value of negative 3. Negative 3, 1. Negative 3, 4. Okay? It's going to go through all of these points. Now for the other line, it's not in slope-intercept form. I could graph it by the intercepts. I could graph it by plotting points. I want to put it in slope-intercept form, so I'm going to solve for the y. I'm going to start by subtracting the x over. So it's a negative x and a positive 6. And then I'm going to divide everything by a 3. So that negative gets divided by a 3, so it's a negative 1 over 3, really. And then 6 divided by 3 is a 2. So I start at 2. I go down 1 over 3. Or it could go the other direction. Didn't go so well. So again, we can see that we have a solution is at -3, +3. Other things that we can have lines that are consistent and independent. This right over here is actually called inconsistent. Have no points in common. These are consistent and independent. They are separate lines. And then if you have two lines that end up to be the same exact line, we call it consistent dependent. Again, there should be another image for that. But here we are graphing systems of equations carefully.